Hello everyone, in this video we are going to learn exercise 2.2. In the previous video I discussed exercise 2.1. If you didn't watch that video, the link is in the description, watch it. Okay, the first bit is, if set A is equals to 1, 2, 3, 4 and set B is equals to 1, 2, 3, 5, 6, then find A intersection B and B intersection A. Are they equal? So first I am solving A intersection B. Set A is 1, 2, 3, 4 intersection. Set B is 1, 2, 3, 5, 6. So here A intersection is nothing but the elements which are common in both the sets. Those elements we need to write. Here 1 is there, here also 1 is there, so 1. Here 2 is there, here also 2 is there, 2. Here 3 is there, here also 3 is there, 3. Here 4 is there, here 4 is not there, so we should not write. Here 5 is there, but 5 is not there in the first set. Here 6 is there, but 6 is not there in the first set. So only 1, 2, 3 are the common elements in both the sets. So A intersection B is equals to 1, 2, 3. Next, I am writing B intersection A. Set B is 1, 2, 3, 5, 6 intersection. Set A is 1, 2, 3, 4. So if we observe the common elements from these two sets, here element 1 is there, here also element 1 is there, so element 1 is confirmed. Element 2, element 2, so element 2, element 3, element 3, element 3. Next, here element 5 is there, but 5 is not there in this. Here element 6 is there, in this element 6 is not there. Here element 4 is there, but element 4 is not there here. So B intersection C A is 1, 2, 3. So what do you observe from this? Or else is asking, are they equal? A intersection B is 1, 2, 3. B intersection A also 1, 2, 3. So we can conclude A intersection B is equal to B intersection A. Okay, next question. If set A is equals to 0 to 4, then find A intersection 5 and A intersection A and comment on that. So first one I am solving, that is A intersection empty set. So set A is 0 to 4 intersection and empty set. So now if we observe these two sets, single element is also not common, because in the empty set elements are not there, so no common elements. This is nothing but empty set. Next, A intersection A. Set A is 0 to 4 intersection, again set A only, that is 0 to 4. Now if we observe the elements which are common in these two sets, here 0 is there, here also 0 is there, so 0. Here 2 is there, here also 2 is there, so 2. Here 4 is there, here also 4 is there, so 4. 0, 2, 4. Here 0, 2, 4 is nothing but the set A itself, so this is again set A. So now he is asking to comment on this. So A intersection empty set is nothing but empty set, and A intersection A is equals to A. Okay, third bit is, if set A is equals to 2, 4, 6, 8, 10 and set B is equals to 3, 6, 9, 12, 15, then find A minus B and B minus A. First I am solving A minus B. Set A is 2, 4, 6, 8, 10 minus set B is 3, 6, 9, 12, 15. Here we need to find A minus B. A minus B is nothing but from the set A, we need to remove all the elements which are present in set B. So here 2 is there, in the set B 2 is not there, so we want that 2. Here element 4 is there, here element 4 is not there, so we want that element 4 also. Here element 6 is there, the same element 6 is there in set B also, so remove that 6. Here 8 is there, 8 is not there, so write that 8. Next, here element 10 is there, element 10 is not there, so write that element 10 also. A minus B is nothing but from the total set A, we need to remove all the elements which are there in B. So only element 6 is there in set B, so that's why we remove that element 6. So A minus B is equals to 2, 4, 8, 10. Next, and find B minus A. B minus A. So first we need to write set B, that is 3, 6, 9, 12, 15 minus set A 2, 4, 6, 8 and 10. So now B minus A means from the set to B we need to remove. Here 3 is there, here 3 is not there, so write that 3. Here 6 is there, here also 6 is there, so remove that 6. Here 9 is there, here 9 is not there, so write that 9. Here 12 is there, here 12 is not there, so write that 12. Here 15 is there, here 15 is not there, so write that 15 also. From the total set B, we removed all the elements which are there in set A. That is only element 6 is present in this. So that's why we removed that only 6. So 3, 9, 12 and 15. Now if we observe these two sets A minus B and B minus A clearly, easily we can say A minus B is 2, 4, 8, 10 and B minus A is 3, 9, 12, 15. Both are completely different. So we can conclude A minus B is not equal to B minus A. Okay, next, fourth question. If A and B are the two sets such that A is a subset of B. A is a subset of B. So set A and set B we need to take. A is a subset of B means set A is smaller than set B. So if set A contains 1, 2, 3 elements and set B should contain all those elements 1, 2, 3 as well as some other extra elements also. Every element of set A is there in set B and set B has more elements also. So in this case we can say A is a subset of B. And then what is asking, what is A union B? A union B, if we take set A is 1, 2, 3 union set B is 1, 2, 3, 4, 5. So 1, 2, 3 union 1, 2, 3, 4, 5 is nothing but 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is nothing but the set B again. So from this we can conclude if A is a subset of B, then A union B is equals to B. A is a subset of B means B is the biggest set. So if we are doing the union, always the answer will be the biggest set only. In case if we are doing intersection, the answer will be the smallest set, that is set A. Okay, next, bit number 5. Let set A is equals to x such that x is a natural number and set B is equals to x such that x is an even natural number. Set C is equals to x such that x is an odd natural number and set D is equals to x such that x is a prime number. And he is asking find A intersection B, A intersection C, A intersection D, B intersection C, B intersection D and C intersection D. So first, the given four sets A, B, C, D are in the set builder form. First, I will convert those set builder forms to roster form. So set A is equals to x such that x is a natural number 1, 2, 3, 4, 5, 6 and so on. Next, set B x such that x is an even natural number. So 2, 4, 6, 8, 10 and so on. Next, set C. X such that X is an odd natural number. 1, 3, 5, 7, 9, 11 and so on. Next, set D is equals to X such that X is a prime number. Prime numbers total 2, 3, 5, 7, 11 and so on. Now let us find out one by one. First, A intersection B. Set A is 1, 2, 3, 4, 5, 6 and set B is only even numbers. Natural numbers, even numbers. So we are finding A intersection B. A is total natural numbers list. Intersection B is only even numbers. 2, 4, 6, 8 and so on. Now if we observe the common elements from these, 2 is there, 2, 4 is there, 4, in this 6 will be there, here also 6 is there, 6 and so on. 2, 4, 6 and so on. Then next he is asking to find A intersection C. Set A is all the natural numbers and set C is all the odd numbers. Natural numbers, intersection, odd numbers. A intersection C. A is total natural numbers list. Intersection C is total odd numbers 1, 3, 5, 7 and so on. If we check the common elements from both these, here 1, 3, 5 and so on. So A intersection C is equals to 1, 3, 5, 7, 9, 11 and so on. And next one is A intersection D. A is total natural number set and D is prime numbers. So total natural numbers intersection prime numbers. A intersection D. A is natural numbers 1, 2, 3, 4, 5, 6, 7, 8 and so on. Intersection D is prime numbers 2, 3, 5, 7, 11, 13 and so on. Now if we observe the common, here 2 is there, here also 2 is there. Here 3, here also 3. Here 5, here also 5. Here 7, here also 7 and so on. So this is A intersection D. Set of natural numbers, intersection set of prime numbers. Okay, next question is asking B intersection C. Set B is even numbers and set C is odd numbers. Set B is even numbers and set C is odd numbers. In the even numbers and in the odd numbers, which element will be common? This is total even number set and this is total odd number set. If we observe the elements, single element is also not common. So B intersection C will be empty set because even numbers and odd numbers doesn't have any common element. So empty set. B intersection C will be empty set. B intersection C will be an empty set because set B is even numbers and set C is odd numbers. Even numbers, odd numbers doesn't have any common element. So that's why B intersection C will be empty set. Next one, find B intersection D. Set B is even numbers and set D is prime numbers. In the total even numbers list as well as prime numbers list, which are the common elements we have? We are finding B intersection D. B is total even numbers and so on. Intersection D is prime numbers 2, 3, 5, 7 and so on. Now if we observe this even numbers set, intersection, prime number set, which elements are common? Only the number 2 is common because only 2 is the even even prime. It means in the total list of even numbers, only number 2 is the prime number. Remaining all even numbers are not prime numbers. So the intersection of even numbers and prime numbers will be 2. Okay, next last question. C intersection D. C is total set odd numbers and D is a set of prime numbers. So what are the common elements in the odd numbers and prime numbers? C intersection D. Set C is odd numbers 1, 3, 5, 7, 9, 11 and so on. Intersection D is prime numbers 2, 3, 5, 7 and so on. Now if we observe the common elements in this, here 3 is there, here also 3 is there, so 3 will come. Here 5, here also 5. Here 7, here also 7. Here 11 will be there, here also 11 will be there and so on. So C intersection D is equals to 3, 5, 7, 11 and so on. Okay, next, sixth bit. If set A is equals to 3, 6, 9, 12, 15, 18, 21. Set B is equals to 4, 8, 12, 16, 20. Set C is equals to 2, 4, 6, 8, 10, 12, 14, 16. And set D is equals to 5, 10, 15, 20. And he is asking to find some questions. So first one, find A minus B. So first, if I read the set A, that is 3, 6, 9, 12, 15, 18, 21. Minus set B 4, 8, 12, 16, 20. A minus B is nothing but from the set A we need to remove the elements which are there in set B. Here 3 is there, here 3 is not there, so write that 3. Next, here 6 is there, here 6 is not there, so write that 6 also. Here 9 is there, here 9 is not there, so write that 9 also. Here number 12 is there, here also 12 is there, so remove that 12. Here 15 is there, here 15 is not there, write that 15. Here 18 is there, here 18 is not there, so write that 18. Here 21 is there, here 21 is not there, so write that 21 also. So A minus B is equals to 3, 6, 9, 15, 18, 21. In the total set A, only number 12 is there in set B also. That's why we removed that 12 and remaining all the elements we wrote as it is. Okay, next question is A minus C. I wrote all the set A elements and set C elements. Now, A minus C, it means from the set A, we need to remove all the elements which are there in set C. Here 3 is there, here 3 is not there, so write that 3. Here 6 is there, here also 6 is there, so remove that 6. Here 9 is there, here 9 not there, so write that 9. Here 12 is there, here also 12 is there, so remove that 12. Here 15 is there, here 15 is not there, so write that 15. Here 18 is there, here 18 is not there, so write that 18. Here 21 is there, here 21 is not there, so write that 21 also. So A minus C is equals to 3, 9, 15, 18 and 21. The next question, A minus D. What is the value of A minus D? Set A, 3 multiples, 3, 6, 9, 12, 15, 18, 21 minus set D. Set D is 5 table. 5, 10, 15, 20. So now let us solve this. A minus D. Here 3 is there, here 3 is not there, so write that 3. Here 3 is there, here 6 is there, here 6 is not there, write that 6. Here 9 is there, here 9 not there, write that 9. Here 12 is there, here 12 not there, so write that 12. Here 15 is there, here also 15 is there, so remove that 15. Here 18 is there, here 18 not there, write that 18. Here 21 is there, here 21 not there, so write that 21. So A minus D is equals to 3, 6, 9, 12, 18 and 21. Next one is B minus A. Set B has elements 4, 8, 12, 16, 20 minus set A have 3 table till 21. 3, 6, 9, 12, 15, 18 and 21. Now we are finding B minus A. So here 4 is there, here 4 not there. So write that 4. Here 8 is there, here 8 not there, write that 8. Here 12 is there, here also 12 is there, so remove that 12. Here 16 is there, here 16 not there, so write that 16. Here 20 is there, here 20 not there, so write that 20. So B minus A will be having 4, 8, 16, 20. Next one is C minus A. First set C I am writing 2, 4, 6, 8, 10, 12, 14, 16 minus set A 3 1s are 3, 3 2s are 6, 3 3s are 9, 2 4s are 12, 3 5s are 15, 3 6 are 18, 3 7 21. So set C I wrote as well as set A also I wrote. So now if we observe this C minus A, from set C we need to remove all the elements which are there in set A also. So if we observe that clearly, here 2 is there, here 2 is not there, so write that 2. Here 4 is there, here 4 is not there, so write that 4. Here 6 is there, here also 6 is there, so remove that 6. Here 8 is there, here 8 not there, write 8. Here 10 is there, here 10 not there, so write 10. Here 12 is there, here also 12 is there, so remove that 12. Here 14 is there, here 14 not there, so write that 14. Here 16 is there, here 16 is not there, so write that 16 also. So C minus A is equals to 2, 4, 8, 10, 14 and 16. Next question is find D minus A. Set D has elements 5, 10, 15, 20 minus set A has 3, 6, 9, 12, 15, 18 till 21. Now if you observe D minus A, here 5 is there, here 5 not there, so write 5. Here 10 is there, here 10 is not there, so write 10. Here 15 is there, here also 15 is there, so remove that 15. Here 20 is there, here 20 not there, so write that 20. So D minus A is equals to 5, 10, 20. Next one is find B minus C. Set B if we write 4, 8, 12, 16, 20 minus set C, all even numbers till 16. 2, 4, 6, 8, 10, 12, 14 and 16. So if we observe this B minus C, here 4 is there, here also 4 is there, so remove. Here also 8 is there, here also 8 is there, so remove. Here 12 is there, here also 12 is there, so remove. Here 16 is there, here also 16 is there, so remove. Here 20 is there, that's 20 is not there in the set C. So B minus C will be having only one element, 20. Okay, next he has to find B minus D also. B minus D. Set B if we write 4, 8, 12, 16, 20 minus set D if we write 5, 10, 15, 20. So now if we find this B minus D, here 4 is there, here 4 not there, so write that 4. Here 8 is there, here 8 not there, so write 8. Here 12 is there, here 12 not there, so write 12. Here 16 is there, 16 not there, so write 16. Here 20 is there, here also 20 is there, so remove that 20. So B minus D will be having 4, 8, 12, 16. Next, find C minus B. C contains even numbers till 16. 2, 4, 6, 8, 10, 12, 14, 16 minus set B 4, 8, 12, 16, 20. Now if we find this C minus B, 2 is there, here 2 is not there, so write. 4 is there, 4 is there, so remove 4. 6 is there, 6 not there, so write 6. 8 is there, 8 is there, so remove 8. 10 is there, 10 not there, so write 10. 12 is there, 12 is there, so remove 12. 14 is there, 14 not there, so write 14. 16 is there, 16 is there, so remove 16. So C minus B has 2, 6, 10, 14. Next, in this last question, find D minus B. So D has 5 table till 20, 5, 10, 15, 20 minus set B. Set B has 4 table till 20. 4 1 8, 4 2 8, 4 3 12, 4 4 16, 4 5 20. So now if we solve this D minus B, 5 is there, 5 not there, so write 5. 10 is there, 10 not there, so write 10. 15 is there, 15 not there, so write 15. Here 20 is there, here also 20 is there, so remove that 20. So then D minus B is equals to 5, 10, 15. And this seventh bit is the last bit in the second exercise. Okay, if we observe the first one, 2, 3, 4, 5 and 3, 6. Two sets are given. One set 2, 3, 4, 5 and the second set 3, 6. And he is saying those two sets are disjoint sets. Just we need to write whether it is a true statement or false statement. First of all, what is a disjoint set? If two sets does not have any common element, then those two sets are said to be disjoint sets. First, let us check whether those two given sets having any common element or not. Here element 3, here element 3 is common in both the sets, so this is not a disjoint set, but he gave it as a disjoint set, so this will become false statement. Next, A, E, I, O, U and A, B, C, D are disjoint sets. In this also, element A is common in both the sets. Again, these two are not disjoints, but he gave those are disjoint, so this is false statement. Next, 2, 6, 10, 14 and 3, 7, 11, 15. If we observe these two sets, single element is also not common. So compulsory these two sets are disjoint. Yes, he also gave it as disjoint sets only. So this statement is true statement. Next, 2, 6, 10 and 3, 7, 11 are disjoint sets. If we observe these two sets clearly, all the elements are different, no common element, so these two are also disjoint. Yes, he also gave those two are disjoint sets, so this statement is true statement. Okay, till now if you didn't subscribe to my channel, subscribe for more videos. Thank you.